Hello everyone and welcome to the continuation of the JavaScript Basics lecture in this part 2. So in the previous course we covered the main primitives of JavaScript, the 7 of them, and today we're going to look at something called objects. Alright, so primitives are called primitive because their values contain only a single thing, be it a string or a number or whatever. In contrast, objects are used to store keyed collections of various data and more complex entities. In JavaScript, objects penetrate almost every aspect of the language, so we must truly and deeply understand them first before going in depth anywhere else. In JavaScript, the object has various subtypes, but they're still an object under the hood. In this lecture, we will be covering only the regular object, index collections, or better known as arrays, then date object, and some keyed collections like map and set, but we will only touch them really shortly. The function is out of scope for this lecture because you will be covering it in later steps. Now, a regular object may be created with figure brackets, as you can see in the slide, with an optional list of properties. A property is a key-value pair where key is a string, it's also known as a property name, and value, which can be basically anything. We can imagine an object as a cabinet with signed files. Every piece of data is stored in its file by the key. It's easy to find the file by its name or add, remove a file. These helpful infographics were taken from javascript.info. I think it's pretty clear and easy to understand with the file analogy. Now, an empty object or an empty cabinet, as you can see in the second picture, can be created using one of the two syntaxes, either using the object constructor with the new object or basically using the figure brackets, as I mentioned before. The second way is preferred. It's really rarely when you would need the object constructor, and the figure brackets is way shorter. Now, as we can see in the third example, we can immediately put some properties into the figure brackets as key value pairs. For example, name, John, age, 30. A property has a key, also known as name or identifier before the colon, and a value to the right of it. In the user object, there are two properties. The first property has the name and the value John. The second one has the name age and the value 30. The resulting user object can be imagined as a cabinet with two signed files labeled name and age, as we can see in the picture below the code. Alright, so let's move on to the code editor to show some live examples. Alright, so we have the same user object we had in the slides. We have name, age, and now I'm going to show you how we can actually access these properties. So to do that, we use the so-called dot notation. So user.name, and we access the name property. We can do that for age as well, and we can just console log out the whole user, which basically just shows us all of the properties it currently has. We can also use the delete keyword to actually remove properties from an object. As we can see, user only has age now, and name is undefined. Now, object property names are usually single-worded, but that doesn't always have to be the case. Although, in order to define a multi-word property name, we will need some special treatment. So all we need to do to make this work is just put the property name inside the quotes. And now it's going to work. Let's see if it does. We can see that the property has been added. Now, how do we actually access it? Because this is not going to work. As we can see, we have an error. And to fix this, again, we need to wrap the accessor inside brackets. And of course, wrap the text inside quotes. And now we got it. Accessing by brackets is usually called bracket notation. We can access any key, name, age, whatever, it all works. Now we can also use bracket notation to add new properties to our object, like this. Let's check it out. It's right there. Now we could have also used the dot notation to define the new property by using user.newProp equals some new prop, which is actually the preferred way of defining single-worded properties. But I just want to show you the bracket notation for now. So let's try and access our new property using the bracket notation. And it's right there, some new prop. Now we can also use the square brackets in an object literal when creating the object. That's called computed properties. For example, let's create this prop right here. Now the meaning of a computed property is simple. In our case, this means that the property name should be taken from the variable key. So we run the program and the prompt opens up. I know you can barely see it, but it's there. And it's asking, what do you want to know about the user? So the default value is name, so we click enter. And we can see in the console the value John. Now to help you better understand this, key is currently name. So we're basically just doing user bracket notation name, and it's giving us John. We can run the program again, and this time input age, and we get 30. And now this will not work with the dot notation. Let's see. We input name and we get undefined. Because basically when we use dot notation, it's no longer referring to the key variable, but to the actual key property that is not currently present in the user. And it correctly shows us undefined. Now, if we were to actually define a property called key, then it would work. Let's try it out. It returns oops, which is perhaps not expected, but that's just how dot notation works. It ignores the key variable and it just tries to access the property key. So another cool example with computed properties is that we can actually set the property name on creation. For example, we have a prompt here which says, which fruit do you want to buy? Let's try and do it. So the prompt opens up. We have apple as the default value and we click enter and we get 5 in the console. Let's actually switch this up to use bracket notation. We run the code again, input peer this time, and we still get 5. Now, it doesn't even matter anymore what you call the fruit variable. It's always going to work because we are actually using the dynamically calculated value on the console log as well. So it's always going to return the property name that we specified. Let's look at what the actual bag object is. Let's run the program again, input apple, and we see that we just have a plain object with the only property apple. Let's try and do peer this time. And now we have an object with the single property peer. Now we can also do advanced operations on these computed values. For example, we can add a string, computers, see what happens. So input apple and we get apple computers as the property name. You might also remember the reserved keywords from the previous lectures like let, var, also return. Well, you can't really use them for naming variables, but for naming property names, it's no problem at all. So let's see if this works. 1, 2, 3. So yeah, it kind of works. And I'm saying kinda because you shouldn't really be doing this. It's kind of confusing. So yeah, I'm just showing this off. Although there is one limitation to object naming. Basically, any property name you give the object, it's just going to get converted to a string. So basically, if we define the property name as 0, it's going to be the same as we would define it as a string 0. So let's try 0, it returns as test. Let's try the 0 as a string, it also returns test. Because basically, this right here is actually the string 0. Now, we also need to learn how to actually check if a property exists inside an object. And there are a few ways to do that. The first one is pretty simple. We just basically check if the property is equal undefined. And if it is, then it's not inside the object. There's also a special operator in for that, which returns true or false depending on whether the property is inside the object. It returns false now, which is also correct. Let's add a few new properties here. and try checking whether they exist inside the user object. Let's try name, we get true, age, also true. We can also declare a variable for the property name to be checked and just use it like this. Still returns true. Now you might have liked the previous approach where we check for undefined, but let's see what happens when the key is present but its value is undefined. So we console log out user.name equals undefined, which returns true, and that would mean that the property does not exist, right? But if we use the in, we will see that it returns true. So that means that name is actually present in the object, it's just undefined. Important topic I want to cover is object references and copying them. So one of the fundamental differences of objects versus primitives in that objects are stored and copied by reference, whereas primitive values, strings, numbers, booleans are always copied as a whole value. So I will show an example, and let's start with a primitive such as a string. So let's define a variable phrase, give it some value, define some other variable, and just pass in phrase as its value. So right now text should be equal to phrase, and that's no surprise. Phrase is also unaffected. So what happens if we actually change the text now to something else? Let's see, phrase still remains hello, and text is now bye, which is no surprise. But objects do behave a bit differently. To show you what I mean, let's create an object, give it some name property, and let's create another and assign the user to it. So basically, user is now our created object, and person is also the same object, right? But what happens if I would change the property of person to something else? Let's see. Let's move the console log after that. Okay, so let's console this out, and we can see that it's Pete. But what about the user? It's also Pete. So what happens is basically person is pointing to the same object as the user since we assigned it, and since objects are assigned by reference and not by value, we have basically modified the original object. So at this point in time, person and user are basically the same original object, which was the name John. So if we modify user or person, we are modifying the same object. But what about equality in this case? Let's try to figure that out. So I'm going to create two objects, which are basically just two empty objects. They are identical, right? So let's try to evaluate that. It returns false. And again, this might be unexpected to you, but once you think about it, objects are also being compared not by value, but by reference. And since we have created two unrelated objects, they are pointing to different things in memory, to be technical about it. But to simply just say that they are two separate entities, they are not related to each other. We have not passed the reference to each other, so they are two different things. And that's why they are not equal. But if we were to assign A to B, then this would return true, because right now they're pointing to the same exact object. Let's try and figure out how do you actually make a copy of an object. So again, we're going to create a simple object. Also create a variable to store the copy. And now there are multiple ways to approach this. Let's try using the for in loop first. What it does on a high level is basically replicate the structure of the existing object by iterating over its properties and copying them on a primitive level, basically to the clone object. So by console logging the clone out, we see that we have a copy now and user is unaffected. And since all of the user's properties are primitives, they got copied by value, and basically altering them won't affect the original, as we can see here. This is the clone object, and this is the user object. There's one more way we can achieve basically the same behavior. So that's by using object assign. Its first parameter is the target object, or rather the object to which we will apply the source's properties to, and of course it is the object that's going to get returned after it's done being modified. And all of the other following parameters are basically source objects. So basically these are the objects containing the properties that you want to apply to the source. And in our case, we want to apply the user's properties to the clone variable. So the user is the source and clone is the target. Let's see what happens. We console it out and we see that we have copied all of the properties from user to the clone object. And again, in our case, all of the user properties are primitives, so they don't get mutated if we change it in the clone object. So we console out user, we see that it's still John, and clone is Pete. Now I have also mentioned that object assign takes any amount of parameters you want. So basically the first parameter is the target and all of the others are just sources. So let's try to provide multiple sources this time. So let's create two variables, permissions 1, permissions 2, and try to assign them both to the clone object. So we just separate them by commas and see what happens. Let's delete this since we don't need it now, and let's console log out the clone object. And as you can see from the console, clone now has users properties, permission 1 properties, and permission 2 properties. I think it's also worth mentioning that duplicate properties are going to get overwritten by the source. So for example, user already has the property name, and if we try to assign it another object with the property name, it's going to get overwritten, as we can see in the console. It got turned into Pete. Now, you don't necessarily need to create an empty object every time you try to copy. There's a simpler way. You just need to specify an empty object as the target and basically do everything else. And there we go. We get the same thing. Clone is now a copy of user. Now, up until now, we've been working with primitive property values. So let's try to make a property an object itself and see what happens. So we're just going to create a simple object, sizes, height, width, and let's try to actually make a copy of it right now. Nothing special, it got copied. But what do you think is going to happen if we try to change the sizes property, for example, the height? Okay, so the clone got modified, that's no surprise. What about the user? And as you can see in the console, user also got modified. Now, why is that? When we're only dealing with primitive values as we did before, it's no problem because the algorithm just copies them by value. But once it means an object, it basically just copies it by reference, as we have seen before in our examples. So the resulting object is not a copy, but a reference to the original object. And that's why we are seeing these mutations. That means if I try to compare the clone sizes property with the user sizes property, I should get true, as it's, oops, sorry about that. With the user sizes property, I should get true, as it's the same object. The main object, user and clone, are not the same. So this is also called a shallow copy because it only copies the primitive values, but if it encounters an object, it's just going to copy by reference. Now there's one more way to actually perform a shallow copy with the new spread syntax, and it's basically just this. Curly braces, 3 dots, and basically the source. And we get the copy. And again, this is the same as object assign. It will create a shallow copy, but I think that the syntax is a bit shorter and easier to remember, so I actually prefer it. So we have discussed about all of the ways how we can create shallow copies, but what if we want to create a deep copy? Well, a deep copy is basically the opposite of a shallow copy. It actually copies all of the objects, all of the nested objects, not by reference, but by actual value. And there are some ways, some more better than the others. For example, the easiest way would just to be to convert the object into JSON and then convert it back to an object, but it does have its limitations. For example, it won't copy any functions, it won't copy dates, and it's really slow. So we're not going to be covering the JSON to object conversion. There's also another way. Basically, you can just use the same principles as we did, but create a custom function that once an object is detected, it recursively just calls itself again on the object and again and again and again. Of course, There are libraries out there like Lodash that has this deep copy function, which works in the way that I just told you. And this would be the preferred approach. I mean, it's better than the JSON to object because it's, well, faster for starters, and it's a bit easier to understand. I mean, the JSON to object is pretty much a JavaScript thing, I would say. Yeah, so before 2022, we were pretty much stuck with these two solutions. Either create your own function or use the JSON to object conversion. But at the start of 2022, JavaScript released a new global function called structure clone. And its support is currently pretty limited. I think only Node 17 supports it, and I think the newest version of Firefox. But I think that in the nearest future, it will be available to more and more engines. For example, Chrome, Edge, of course, Opera, Safari, and so on. It might even be the case that by the time you're watching this video, it's already supported by most of the popular engines. So let's quickly see how it works. And again, I have my trusty user object. I will create a variable clone, and I will call the structured clone method, provided the source, and let's see what happens. So consoling that out, I get the copy, which shouldn't really surprise us anymore. But what happens when I try to change the sizes property, for example, height? Let's see what happens. Let's console log clone out and the user. And as we can see, we have successfully modified only the clone properties and the user stayed as it was, which basically solves all of our problems. But please do remember that this has very limited support. And don't do deep copies if you don't actually need a deep copy, because a shallow copy is always more performant than a deep one. Now, one more important side effect of storing objects as references is that an object declared as const can be modified. For example, let's define an object first, give it name, John again, and try to modify one of its properties. JavaScript won't give us any error. And let's see if I'm right here. Yep, the name has been changed to Pete and there's no error. But what happens if I actually try to reassign the user variable? Now JavaScript throws an error, because we're trying to reassign the value. And that is a big difference you need to understand. Now let's look at how we can actually iterate through the keys of an object. So for that we use the for in loop, and it's quite different from the for loop we already learned in the previous course. For this loop you need to define the key in user. And the key is actually a variable, as you can see with the let keyword. And that key variable will store all of the keys from an object. So let's see what it actually stores. As we can see, it basically just returned us all of the free keys available to the user object. Now, the key doesn't necessarily have to be called key. You can call it whatever you want. Let's say I, but I'll just prefer key. Now, only getting the property name is not really useful to us, so this is how you actually access the values. You use the same bracket notation as we did before. Now we can also access the object keys by using the actual object keys notation. Let's see what it gets us. It returns an array of all the keys. We can also get the values in a similar way. And a thing called entries, which is like an array of arrays. Here we have the key, the value, the key, the value, and again, the key and the value. And on a high level, that is pretty much it for regular objects. Let's move on to arrays. Objects allow you to store keyed collections of values, and that is fine. But quite often we find that we need an ordered collection, where we have a first, a second, a third element, and so on. For example, we need that to store a list of something like users, goods, HTML elements, etc. It's not convenient to use an object here because it provides no methods to manage the order of elements. We can't insert a new property between the existing ones. Objects are just not meant for that. There also exists a special data structure named array to store ordered collections, but remember that under the hood it's still an object. There are two syntaxes for creating an empty array, as you can see in the slide. So there's the constructor way, as we saw with the object, and the bracket notation. I, again, prefer the second one because it's way shorter, it's easier to understand, and new array actually has a few unexpected bugs that you might run into, and we will discuss them a bit later. But for now, just try to remember that the bracket notation is the preferred way of creating an empty array. We can also pre-populate the array, as we can see in the third line. In this example, we give it apple, orange, and plum, three strings, and that basically creates a new array with three objects, three strings to be specific: apple, orange, and plum. Let's move on to the code editor for better examples. So this is the same array as we saw in the slides. Array elements are numbered, starting with 0, and we can get an element by its number in square brackets. So 0 gives us apple, 1 gives us orange, 2 gives us plum. We can also replace elements like this, basically assign a new value to it. So currently fruits 2 will be cherry. And the whole fruits array is apple, orange, and cherry instead of plum. There's also the built-in length property, which just returns an integer. Pretty self-explanatory. Now, one more important thing. In JavaScript, arrays can hold any type of values, be it string, boolean, number, null, undefined, object, all at the same time in a single array. So if we console log this out, we will see all of the values normally, no errors, which is pretty great. Okay, so we've covered how to access arrays, and now we need to cover how to actually add new elements to an array. So let's get back to our simple fruits array. And the most straightforward way is just to assign a new value to the index that is the length of the array. And that is because arrays are 0 index based. That's why length is basically 3, for example, but the last element is found at index 2. So if we add an element at index 3, we are basically adding it to the end of the array. Now, the preferred approach to actually add new elements is the push method. The push method basically accepts multiple parameters, and what it does with them is simply just adds them to the array. So if we run this program, we see that banana was successfully added to the array. Now let's try specifying multiple parameters, for example, tomato, plum, and see what happened. So yeah, they all got added. Now push adds elements to the end of the array, but what if we want to add elements to the front of the array? We use unshift for that, and we can see now the elements are added to the front of the array. This of course also works with a single argument. And yeah, that's pretty much it for the unshift and push. But what if I want to actually remove elements from the array? Well, we use pop for that. Now what pop does is basically removes the last element from an array and returns it. As we can see, it returned cherry, and the resulting array is apple and pear. So pop removes an element from the end of the array, and shift removes it from the start of the array. Again, it returns the element that was removed, and the resulting object is pear and cherry. Now, do keep in mind that pop and push are the most performant methods, and unshift and shift are the least performant methods. So do keep that in mind when you use them. The reason for this performance difference is in the way that these methods operate. So what pop and push do, basically they just remove or add an element to the end of the array, which just adds a new element, updates the length by 1, and basically keeps all of the other members untouched. I mean, their indexes don't change. And meanwhile, shift and unshift adds an element to the beginning of the array. So now it needs to, of course, update the length property because that's a new element. And he also needs to move all of the remaining elements by 1 index. If, for example, banana was index 0, we unshift a new element to the array, banana becomes 1. This might seem like a small thing, but imagine if you have an array of 1 million entries. You would need to do 1 million operations when you unshift one value, so do keep that in mind when you use them. I mean, unshift and shift do have their use cases, but I would recommend you not overusing them because of these performance issues. Now, do be aware that arrays might look like a different data type, but they're still objects. And that means they're also passed by reference. So if we assign R to fruits and try to actually compare them, we will get true, because they're both pointing at the same array. And that also means if I mutate array, for example by pushing, this will also affect the original fruits array. So how do we make a shallow copy from arrays? We can also use the already described spread operator as we did with objects, and now we have ourselves a shallow copy. So the evaluation of equality is false and the original array is left untouched while the other one is updated. So now we're going to look at all the different ways we can iterate through our arrays. So the most basic example is by using a classical for loop. So we just define the UI, limit it to the fruits length, of course add, and there we have it. Basically the I is the index and we access fruits by it and we get the result. A simpler but similar approach would be to use for of loop. So we define the key, in this case it's going to be the actual fruit of fruits, and then we just console log out the fruit. Oh, sorry, you need to console log out the actual fruit. So now we get the answer. To my mind, this is a simpler approach. It's definitely less verbose, so you should prefer it over the for loop. Also, technically, because arrays are objects, it's also possible to use for in. So in this case, we won't get the values, but we're going to get the keys, which are basically the indexes. But generally, do avoid using for in for arrays because it's generally slower than the for of. There are of course many other ways how to iterate through arrays, but these are the main ones. Let's continue with the gotcha I mentioned at the beginning with the array constructor. Let's provide a 2 here as the only member, and let's log out the only element it has. Ooh, it's undefined. Well, that is because if a new array is called with a single argument, which is a number, then it creates an array without items but with the given length, which in our case is 2. So it's basically an array of 2 undefined values. But if we give the constructor more than one argument, it's gonna behave as expected. I want to stress out that this is really rarely used. I mean, the bracket notation is much shorter and easier to remember. Okay, one last thing I want to mention is multi-dimensional arrays. So for example, let's create this matrix here. It's going to be our multi-dimensional array. What multi-dimensional means is basically it's an array within an array. So we have our main array and we have 3 inner arrays inside of it. So how do you actually access it? Well, first of all, let's look at what the matrix is. It's an array of 3 arrays, and that means that we first need to specify which of the 3 arrays we want to access. So let's say I want to access the first one, which is this one. Okay, I get 1, 2, 3, and now I want to access the first element. So I also specify the 0 index, and I get 1. Now same principle applies to other rows. It's basically the first element of the second row is 4, and the last row in the first element is 7. Okay, so now I still want to talk about the remaining methods of arrays because there are so many. And we already covered push, pop, unshift, and shift. So let's take a look at the other methods. So we talked about removing elements using pop and shift, but that only allows us to either remove an element from the start or from the end of an array. So how do we remove something, for example, from the middle of an array? Since an array is an object, we could use delete as we did with the objects. Let's try that. And this is pretty unexpected, right? What delete does on a high level for an array is just sets the element to undefined. But the length, as we see, is still free, so it didn't really remove the element, it just set it to undefined. So the actual way to remove elements from an array is to use splice. And its first argument specifies from which item of the array should we start the deletion. Now the second argument is the number of items to be deleted. Let's just see what happens. So we start at index 1, which is the word there. We have specified to delete one item, so only the word there was deleted, so the resulting array is hello friend. We can also try to specify to start from the beginning and delete two items. And now we're only left with friend. If we delete only one item, we get their friend, since hello was deleted. Now, splice also accepts any number of additional parameters, and they are used to replace the deleted elements, basically. So if we delete two items, we add two items, and we get goodbye their friend, because we deleted hello there, and we replace them with goodbye there. Actually, we don't need to delete anything if we specify the number of items to be deleted to be 0. For example, we're going to start from the index 2, delete 0 items, add what a day. Actually, let's start at the beginning. Oops, it's the comma. Alright, let's see what happens. So nothing got deleted, and we added what a day at the end of the array. Now we can also specify negative numbers for the start, and what that will do is gonna start counting from the end of the array, which in our case is the beginning of the array, and we basically just add text to the beginning. There's also slice. It's much simpler than the similar looking splice, and it accepts only two arguments. The first one is from where to start splicing, and the second one is where to end it. And do be aware that this is not inclusive. That's why we got hello instead of hello there, which would happen with splice. Let's try changing it up. Let's also change the beginning. Oops, that's not gonna work. And there we go. So slice is a bit simpler than splice, so I think there's not much explaining there to be done. Although slice offers one interesting and useful thing. If you don't provide any arguments to it, it's just gonna create a shallow copy of the array. So let's try that. Let's try pushing something into the copy and see whether it mutated the original array. So, as you can see, the original array is untouched, only the copy was affected. So that's just one more way how to create a shallow copy. There's one more useful method called concat. It basically creates a new array that includes values from other arrays and additional items. So it accepts any number of arguments, either arrays or simple values, and the result is a new array containing items from the arguments. And now I'm going to show you one more way how to iterate through arrays. It's by using the for each method. So the syntax is a bit more complex. I know we have not touched functions before, and this is a function, but bear with me. You're going to understand this base syntax on the next lecture. It's still pretty simple, so let's just try it. Console logging item gives us all of the members from the array. Since this is an arrow function, we can actually delete these curly braces and just leave it as is. Still the same. Also, the for each accepts other arguments such as index and array. Let's see what they contain. So item, index, and array. So the item is the actual item, the index is which index it is, and the array is just the general array we are iterating through. Pretty straightforward. We also have a very useful feature, index of, which finds which index the specified element is located in. For example, hello is at index 0. There is at index 1. But what happens if I try to input something that's not there? We get -1. And that's a common response from index of when it doesn't find the element we're looking for. So yeah. Well, what's going to happen if our array is filled with objects? Let's try to first populate it, and I'll show you what I mean. So if we try to search by, let's say, an object literal named John, which is identical to the one in the array, right? It's not going to find it because, again, we're searching by reference. So how do we get around that? There's actually another method called find, which does exactly that. But again, it's a function, so bear with me. What it does is it iterates through the array and returns the value which satisfies our condition. In this case, the condition is item name equals John. So let's see if it finds it. And there we go, it returned the object. But what about the index? Well, there's also a method findIndex, which works the same way, it only returns the index. Oh, and by the way, since this is an arrow function, we can omit the return statement and the curly braces. It will work the same way, only look a lot better. And as usual, this function also accepts the item, the index, and the whole array parameters. Okay, so we know how to get one value, but let's see how we can get multiple values by some condition. Just populate this array a bit more. And imagine you need to return all of the users that are over age of 18, let's say. So for that, we use filter. It works similarly to the find, but we'll see. So we also pass in a condition. So in this case, we want everyone that's above or equal the age of 18. And it returns the two objects. If we change it to 14, it still works. So the difference with find is that filter can return multiple values. And now we're going to do some array transformation. So let's make it so that these are just numbers, like 1, 2, 3, 4, 5. I'm going to introduce you to map, another array method. Now what it does is it iterates all of the values and it transforms them with whatever value you return from the function. For example, I want to multiply each item by 2. Let's see if that worked. And, oh yeah, it does not mutate the original array, so you need to assign it somewhere else. So yeah, now it works. Okay, so I'm going to introduce you to the sort method of arrays. It does exactly what it says, so yeah, there's no explanation here. So let's just call sort without any arguments and see what it does. Well, that doesn't really look correctly sorted, right? That's because if you don't provide any arguments to the sort function, it's just gonna assume that all of the members of the array are strings, and it's gonna sort them alphabetically, which would be correct because 1 is less than 2, right? So how do we fix it so that sort sorts numbers correctly? Well, again, sort accepts a function, so sorry for that. Let's see what A and B are actually. So it just goes for the array comparing two elements one by one. And to actually make sort work with numbers, we need this function to return specific values. -1 if B is greater than A, 1 if B is less than A, and 0 if they're equal. Well, not specifically once, you can actually provide any positive or negative numbers. And that's just what we're going to do now. If A minus B is a negative number, that means that B is greater than A. And we see that it now works. Now, if we'd be trying to sort an array that's filled with only strings, we would have less problems. So we don't actually need this function anymore. We can just use the native sort without any arguments, and it gets sorted correctly. Now, another cool method is reverse, which is also self-explanatory. Let's see what it does though. Yeah, you guessed it, it reverses an array. And do be aware that it does mutate the original array, as you can see from the console. Okay, we have converted that array into a string. Let's see what we can do with it. So we can use split. Actually, it's a string method, but it's closely related to arrays, and we'll see why. Well, it's because it converts a string into an array using the specified delimiter in the parameters, which in our case is a comma and a space. Since this is a string method, we can of course use it on strings, but I'm going to show you a few cool tricks we can do with a single, let's say, word. So first of all, we split it and we get an array of its letters. Then we can do reverse on it, since it's now an array. And finally, we can do join, which is a new method, but what it does is kind of joins all the array elements into a string, and our resulting string is the reversed original. So that was just a quick example of how you can actually combine all of these array and string methods together. And one more time, let's just see what happens when we do join. It joins the array elements into a string with the provided delimiter. For example, we can use a comma here, some weird symbols, anything works. And I saved the best method for last. In my personal opinion, this is the method that people tend to forget the most, and I'm not quite sure why, but that's just my opinion. And the method is reduce. When we need to iterate over an array, we can use for each, for of. When we need to iterate and return the data for each element, we can use map. So the method reduce also belongs to that category of methods, but it's a little bit more intricate. They're used to calculate a single value based on the array, and that is the key point, single value. So this function accepts 4 arguments. The first one is the accumulator, second is item, index, and the array itself. So first of all, let's see what these values actually mean. Oh yeah, I also forgot that we need to return something. Alright, so let's examine the console result. The accumulator is the result of the previous function call. It basically starts with the first item in the array, or you can specify the initial value as the second argument of the reduce function, which I will show a bit later. But since our reduce function only returns the item, our accumulator is basically the item behind each iteration. So it starts with 1, then it's 2, 3, and 4, so it's not really interesting. The item, I think it's pretty self-explanatory. It just iterates through the array and returns each member, except for the first one. The index, again, seen before, array, seen before. So yeah, let's move on to actual usage of this reduce function. Let's only keep the accumulator and item. And since our array is full of numbers, I think the logical approach would be to return the sum of all the items. So let's rename these. And notice how I mentioned sum, which is a single value comprised of all these array members. So what we need to do here to actually get the result is return the sum plus the current number. Since we have not provided an initial value, sum would be 1 by default because this is the first element of the array, but we can also specify it using the second argument of the whole reduce function. And let's run this. It prints out the single number 15, which is the correct sum of all of these numbers. So reduce is useful when we only need one specific combined value of an array. And to finish arrays off, let's specify how do we find out if an element is an array. Because if we use type of, it's not going to return array, it's going to return object. The same for a regular object, because arrays are objects under the hood, right? So how do we differentiate? Well, there's a built-in useful function, array.isArray, and we specify the variable. It returns true or false. So false for the object, true for the array. Pretty straightforward and easy to remember. And that is it for the arrays. I know that it might seem overwhelming with the amount of methods, but we've covered the main methods. There are still plenty of you to read about, but yeah, those are the main methods, and with practice you will I believe that you will learn them by heart. It's pretty simple. I mean, most of the methods are pretty self-explanatory in what they do anyway, so there shouldn't be any problem here. And we can move on to other object subclasses. Let's meet a new built-in object, date. It stores the date, time, and provides methods for their management. For instance, we can use it to store creation or modification times, to actually measure time, or just to print out the current date. To create a new date, we just call the date constructor, as we see in the example on line 1. If we provide no arguments, we will create a new date with the current date and time. If we provide a single integer argument into the constructor, it's just going to create a date with the specified milliseconds passed since 1970, January 1st, UTC 0. This is also called the Unix timestamp. So on the third line, for example, we see that we convert the milliseconds to hours, then multiply it by 24 hours. That means we add one whole day to it, and the result will be 1970, January the 2nd. And JavaScript dates are notorious for being tricky to understand and manipulate, so there are plenty of libraries to choose from, which basically allow you to modify dates using more human understandable formats. Now, if the single argument is a string, then it's parsed automatically. That means we can provide an actual date string in the format of, for example, year, month, then the day. We can also add hours, minutes, seconds, and even milliseconds. And additionally, we can also provide the time zone at the end. In this example right here, we have not provided hours, minutes, seconds, or the time zone. So the hours are automatically set to midnight, and the resulting date might vary according to the time zone you have set on your computer or your environment you're running the code from. So that's just a short, brief intro. Let's move on to the code editor, and I'll show you a few useful methods you can use with the date object. So currently we have a single variable with the new date, and we have provided a date string of 2020 January the 1st. And now we're going to explore a few options on how we can parse the actual date object. For example, we're going to start with getting the year. So the method is get full year. And do be aware that it's not get year, it's get full year. Get year is also available, but it has been made obsolete because basically it doesn't return the full date because of the Y2K problem or the year 2000 problem. Feel free to read about it if you're interested. I will show you what get year does, but just be aware that you should always use get full year. All right, let's see what this does. It returns the single integer 2022. Now we can also do the same thing for months with the get month method, and we get 0. Now why do we get 0? We should have gotten 1, right? Because January is the first month. Well, again, this is 0 based, so January is the 0th month and December is the 11th month. So let's change this to February, and now we get 1. Change it back, 0. Now to get the day of the month, you might be tempted to try get day, but it's actually get date. Get day is reserved for something else. We will figure it out later. Oh, and also notice that get date is not 0 based, so if the day is the first one, we actually get 1. Let's try change this to 2. Yeah, and we get 2 now. So only the get month is 0 based. Okay, so let's try talking about the time now. Since I haven't provided any time in my constructor, it just assumes that it's midnight. So let's try getting the hours now. And we get 2. But why is it 2? I just mentioned that it's set to midnight automatically. Well, I will explain this a bit later, but now let's try to figure out how to get the minutes, seconds, and so on. So the method for get minutes is, of course, get minutes. Oops. Yeah, and we get 0 because it's set to 0 automatically. Seconds as well. You can also get the milliseconds, which will also be 0. And now let's talk about get day. This method returns the day of the week. Now you might notice that this is 0 indexed, but not only that, 0 is Sunday, 1 is Monday, 2 is Tuesday, and so on. So do keep that in mind if you live in a country where Monday is the first day of the week. In this case, Sunday is the first day of the week. And what this method tells us is that 2022 January the 2nd was a Sunday. All right, let's move on. Let's try to increment the day by 1 and see if it changes. Yeah, now it's Monday. 2 days, it's Wednesday. There's also the method getTime, which gives us the Unix timestamp or milliseconds passed from 1970 January the 1st. Okay, so there's just one thing left to figure out. Do you remember when I invoked getHours, I got 2 instead of 0? Well, why do you think is that? Since we have not provided any time zone into our date stamp, it just assumes that it's UTC 0, and I'm currently in GMT plus 2, which is also UTC plus 2, and that's why if it's midnight in UTC, it's actually 2 a.m. in GMT plus 2, because it's plus 2 hours. I hope you get the idea. Now, to actually figure out what is the current offset, we have a handy method getTimeZoneOffset, which returns the difference between UTC and the current time zone in minutes. So since I'm in GMT2, the difference is 2 hours, so 120. Let's try getting the hours again. It's still 2. And to fix this, we can either subtract 2 hours or call the method getUTCHours, which gets the current hours in regards to UTC 0. And this UTC counterpart is available for hours, minutes, seconds, whatever you want. Now I'll show you how to get the actual current time at the given moment. So all we need to do is just call the date now, and it returns, again, the Unix timestamp. It constantly keeps updating, so yeah, it's just the current time. Now if you want to get the Unix timestamp of a specific date, all we need to use is date parse. We just provide a date string to it, and it returns the Unix timestamp for this specific date. So we can also provide, let's say, the hours, the minutes, the seconds. Also, let's try milliseconds this time with the dot. And let's provide the GMT plus 2. So this right here is the full available timestamp you can provide. And we get the Unix timestamp. However many times I click on it, it stays the same. But if I want to use the date methods like getDate, getDay, I still need to convert the timestamp into an actual date object, because currently it's just an integer, milliseconds or a Unix timestamp. So let's do just that. We will use new date. Again, currently we are just providing the milliseconds in the constructor as we did before, and it creates a date object based off of that. So let's try getting different parts of the date. Oh, and I guess this is a good chance to show you the get year problem. You see it returns 122, which is incorrect. And that's again related to the Y2K problem. If you're interested, you can just read more about it. I'm not gonna get into details here, but make sure to always use get full year. Now, since this time we have provided the time zone, we should no longer see problems by getting hours. And there you go, it's now correct. But do be aware that if you will be in a different time zone, it's gonna have different results. So let's check the other methods. And everything seems to be working as expected. So that's just a brief introduction to dates. There's a bit more to it, but these are the main methods, and most of the times you will be using a library anyway, because handling dates in JavaScript is pretty complicated, as you can see. All right, let's move on to the last section of this course. Okay, so the last topic of this course are keyed collections. Now, this is a pretty advanced topic, so I'm not going to get into much detail, but I want you to just get familiar with the data structures map and set found in JavaScript. Now I might be calling them data structures, but if you were following along, they're still just objects under the hood. So let's start with map. Map is a collection of key data items, just like an object, but the main difference is that map allows keys of any type. If you remember, objects only allow you to store string property names. On the other hand, map allows you to use anything for the property name, be it an object, a boolean, a number. You can even use like null as a property name, which would be pretty weird, but you can do that. To make it simpler, imagine that a map is just the same object, only that it allows any type of property names. And of course, there are other differences that we're going to cover, but on a high level, a map is just an object. Now, I have also provided a lot of different methods for map. We're going to cover them in more detail when we go to the live coding. For now, just, I don't know, write them down or just read them through if you want. We're just going to cover map and set on a high level, and then we'll move on to details. Okay, so we covered map, so let's continue on to the set. Now, a set is also a special type of collection. It's like a set of values without keys, which is the difference between map, where each value may occur only once. So that means that there are no duplicates. You can imagine set on a simplified level as an array that only stores unique values. So for example, if you would create an array with the members 1, 1, 2, 2, 3, in the set, if you would do the same thing, create a set from that array, the resulting set would just be the members 1, 2, and 3 because only the unique values are kept. Well, I think it will be easier to understand with concrete examples, so let's move on to the code editor. Alright, so let's actually start by creating the map object. I'm going to use the map constructor here, and let's assign some values to it. We do that by using set. The first argument is the property name, and the second argument is the property value. So let's try assigning multiple types of property names just to demonstrate. So I'm going to assign a string, a number, and a boolean. Okay, so we have set the values. Let's try to access them. You might be tempted to use the bracket notation, but that doesn't work with maps, as we see undefined. The correct way to access properties is to use the method get and specify the property name. So we see that the map correctly returns our property values, even the boolean value. And another cool thing is that maps also support objects as the property names. So let's try that out. Create an object, set it, use the person object, set it to some, let's say that's John. And let's try to access it. We specify, oops, not John, but person, and we get that's John. Now this would not work with regular objects because if we tried to use an object as a property name, it would get converted to string, which is object, which is not correct in our case, but with map we can use any object or any other data type we want. So that's worth remembering. Okay, so how do we actually iterate through the keys of a map? Well, again, we use a for of loop. We just need to specify map.keys. Since it's an iterator, it's going to return all of the keys from the map. Let's see 1, true, and John. We can do a similar thing with values. Oops. Yeah. And of course, map also supports entries, as do arrays and objects. We can also use a for each loop, so let's try that. And this for each also supports the item, the index, and the whole map as its arguments. So let's console log them out. Okay, so the values, the index, and the map object itself. But most of the times we only need the values here. We can also convert some maps into objects using object from entries and assigning it the map entries value. And this is only going to partially work because one of our keys is an object. And as I mentioned before, objects convert all of the property names to strings. That's why we see object, because that is a default string conversion of an object in case it's not specified otherwise. And also we only see our one of the 1 values because 1 and 1 got converted to string and only the second one remained, which is value 2. So we can't really trust maps to be converted into regular objects because regular objects do have some limitations. Maps themselves do have a lot of use cases, so it's worth getting familiar with maps. This is just a short intro, of course, but if you want to dive deeper, feel free to just check it out on MDN or javascript.info because this is a pretty high-level approach to maps. But we are pretty much done with maps, and let's move on to set. Let's start off again by actually creating the set object. It's just new set. And let's assign it some values. Let's create, I would say, 3 objects just to demonstrate. So bear with me here. And adding items to the set is similar as we did with map, so we just do add. Let's add all 3 of them. And let's add John and Pete again, just to demonstrate what a set does. So let's first of all examine what the size of this set currently is. It's 3. And that is because set ignores duplicate values. We have added John and Pete 2 times, and the set just ignored that. Okay, so let's figure out how to iterate through the set. So again, we can use the classical for loop. It's pretty simple. I've done this many times, so just console log out user, and we see that John, Pete, and Mary, and no duplicates are there. So just like objects, we can also use the for each loop. Going to do the same thing. Now the set also has the same keys, values, and entries methods as the map had, but that's basically for compatibility reasons because all of them return the same value, as we will soon find out. Let me show you. So this returns our keys. Values also return the same value. And entries also return the same result. Now another really useful thing we can do with sets is remove duplicates from an array. So let's say we have this array here, let's add some duplicates to it. And I'll show you how we can easily remove them. So we create a set, pass in our array. We don't need the spread operator here, by the way, I'm just, we can also do it like this. And let's for each the set and see what it does, see what it contains. It contains only 5 of the items, so all of the duplicates have been removed. We can also easily convert a set into an array with the spread syntax. So we just spread it out into an array, and it should yield the same result. Let's check it out. Yep, the array with no duplicates. An even shorter approach to this is just to actually create a new set, provide it with the array, and spread the result out, and we still get the same thing. Well, yeah, I prefer it because in this case we don't need to create separate variables for the new set, for the array. We can just directly provide it to the set and receive the no duplicates array. And that is pretty much it for the set. We have covered the most important functionalities. Do keep in mind that set is useful for when you need to store some type of values, any type of values, but you don't want duplicates. So instead of manually checking for duplicates, you can just utilize the set, and it's way more performant than actually checking for duplicates by hand. And yeah, that's about it on a high level. We covered all of the data types available to JavaScript, so 7 primitives and the object type. I hope that you found this course valuable, informative. I tried to be as thorough as possible because it's really hard to fit all of the information about JavaScript in a few lectures in a few hours, but do keep in mind that the point of these lectures is for you to actually figure things out on your own. I just give you the foundation, and you just need to find additional information on whatever interests you more or what you didn't fully understand, because we do have students of different levels. So I don't want to get in too much basic detail here, and I don't want to get into complex details. So according to your level, just choose the right information. You can start with an MDN. That's a really good source. Or you can also use javascript.info. It has a lot of topics covering JavaScript, and it's actually pretty comfortable to use because the topics are split up into categories and you can just go one by one and learn. So yeah, I hope you enjoyed this video, and I'll see you around.